Hi, I'm Kai Hermann from Dresden, Germany, and I want to tell you something about our research project InVerDa, where we intend to make database evolution as agile as common software development. To better understand the benefit of InVerDa, let us compare the state of the art on the left with the database evolution support given by InVerDa on the right. Assume we have a set of applications running on top of a database with a schema and currently existing data. When the developer wants to continue the evolution of the application, this might also include the evolution of the database schema. To make a new schema version available, the developer would write Delta code, which comprises, for instance, views for reading and triggers for writing. Writing this Delta code is already very time-consuming and error-prone. In contrast, with InVerDa, we would write database evolution scripts that are based on schema modification operations, short SMOs. These SMOs allow, for instance, to add columns, to partition tables, to join tables, and so on, so they keep the intention of the developer and allow to generate all the Delta code automatically. These evolution scripts are order of magnitude shorter than traditional SQL and already simplify database evolution a lot. As time goes on, the majority of the users might decide to use the new version of the application, so we also want to physically migrate the database according to this new schema version. Traditionally, the developer will sit down with the database administrator to write an SQL evolution script that evolves the schema, that physically migrates the data, and most importantly, keeps all the data consistent, which is a very error-prone and expensive task in practice. After executing the evolution script, the new version of the application may now work properly on the new schema version. However, all the old applications still work on the former schema version, so the developer again needs to sit down and write Delta code to make the old schema version accessible. This is very error-prone and expensive. In contrast to this, InVerDa allows the database administrator to independently execute migration statements by simply specifying the schema version that should be physically materialized. InVerDa transparently executes this physical migration in the background. This also includes the adaptation of all involved Delta code, so all schema versions stay continuously accessible, and the code required to do this is again orders of magnitudes shorter with InVerDa, so it really realizes foolproof and robust database evolution and migration. To sum up, InVerDa uses a database evolution language based on SMOs to realize coexisting schema versions and transparent physical migration. This should allow database developers to keep the pace with agile software development. Additionally, InVerDa provides two formal guarantees. First, it's shown to be relationally complete, so there should be no need to fall back on traditional SQL. And second, it's shown to be bidirectional, so no matter which schema version is physically materialized, each schema version acts like a full-fledged single schema database for the user. If you are interested in InVerDa, I would like to welcome you to my talk at the SIGMOD conference, or I invite you to read our paper, or you may also visit our website inverda.de, where you can learn more about the concepts of InVerDa or play around with our online demo. Thanks for watching.